Hello. Um, the purpose of this video is to address a couple of issues in what we call the debt sustainability literature. Okay, and it's to tie together two ideas that are out there and to show that they're really the same idea. Okay, so one idea is it's an old idea dating back to the mid 80s. Robert Barrow and Thomas Sargent, and that's the idea of tax smoothing. The idea is that you want to sort of spread out whatever deadweight loss or more properly understood collection costs. Here's the present value of collection cost, and we're writing these down. This is a quadratic function, which means that as taxes rise relative to some long run value or some reference value, our collection cost rises, and because it's quadratic, they're increasing. Okay, so that's a good property of this quadratic. Okay, so we want to minimize the costs, and that's why we want to kind of keep them constant. But the idea is that we're doing this subject to some kind of intertemporal budget constraint, and that's really what this is about. Because I also want to tie in another idea. Olivier Blanchard, a long time ago, wrote a paper, and many other people have written about it, called, we're talking about debt stabilization as a sort of a sustainability criteria. And I have like a little nickname for this. I call this lunchroom sustainability. Why? Because in the IMF, you have two country economists, and they sit down for lunch and they say, "Oh, is the country that you're working on, is their debt sustainable?" So, well, insofar as their primary surplus, which is taxes minus government spending, which we're holding constant here, by the way, but at some level, taxes minus the primary surplus exactly offsets interest payments minus a little tiny bit for growth. Okay, so we're able to stabilize the debt. So what I'm going to show is that once we fit in the budget constraint, because it's a first order condition. It's a first order condition, but it hasn't substituted in any kind of budget constraint. So we're gonna address that. Now, the other thing is I want to remind us that we're working with growth adjusted interest rate. This is the interest rate, the real interest rate. This is the real rate of economic growth. We're just going to call this beta, and we're going to keep with the assumption that of dynamic efficiency, which is that the interest rate exceeds the growth rate. So once again, what we're going to show is that properly understood, these two policies are the same. So the first thing I'm going to do is I'm going to write down the one period budget constraint. Over and over and over again. Period one, today's debt is equal to yesterday's debt times 1 plus the interest rate adjusted for growth plus the primary deficit, which is gamma minus tau. Okay, so in this exercise, as I said, we have a bar here because we're holding this constant. We're going to solve out for this, okay, et cetera, et cetera, et cetera. Okay, so now the idea here is we keep going, and we want to have the same tau star, because that's basically, we might have even put here is equal to tau star. So the question is, what is that tau star? So we have a budget constraint. Now what we do is we start progressively substituting this. So we take the D1, substitute it into here, then D2, substitute it into here, et cetera, et cetera. And what we end up with is this sort of chain where we have today the debt at period t, okay, which is off in the future, which is the initial debt plus the accumulated interest payments. You can see we're taking 1 plus r over 1 plus g to the tth power. Okay, so we're capitalizing, and then also we have the capitalized value of primary surpluses. Okay, but now what I want to do is I want to turn this into a present value. So when I divide through times b to the t to the power t, I'm getting the present value, and I'm doing the same on this side, and I'm doing some mathematical manipulation, and I come with a very, very familiar chain, and that is the present value of the debt here over here on the left-hand side of future debt is equal to current debt plus the present value of primary surpluses. So today's primary surplus plus tomorrow's primary surplus discounted plus next period's primary surplus further discounted, etc., etc. And that's what this is. Now, I'm doing a little bit of manipulation, including I'm factoring out 1 over beta here. So I get this in a very convenient form. 1 plus 1 over beta plus 1 over beta squared plus 1 over beta third, etc., etc. Okay? Now, I want to now introduce the ideas that we're going over an infinite horizon. So this is a limit term. So it's kind of, we're getting closer and closer and closer to the end, but we never get there, of course. And the first thing I want to mention to you, that this whole dude over here, this is what they call an infinite series, that so long as r is greater than g, okay, this converges to 1 over 1 minus 1 over beta. Okay, so this is something that you probably learned in your algebra class and you didn't know how useful it was. It is very useful. Okay, so now I'm going to do some manipulations here, and ultimately I'm going to get 1 over beta here times 1 over beta minus 1 over beta, or let's just take it out. We've got 1 over beta on the bottom and 1 beta on the, we got beta on the bottom here and beta on the top that flips out, and we've got, at the end of the day, we've got 1 over beta minus 1. Okay, now the next thing I want to tell you is, okay, this is the long run budget constraint. We could call it intertemporal solvency or the no Ponzi game condition or the transversality condition, but the interpretation is that over an infinite horizon you pay off your debt, but you pay it off in present value terms. So the present value of the debt has to go to 0. That is the okay. So you can see now we went back here and we got this guy here, which is a very, okay, we're using our infinite series here, and we get this here, and this is equal to 0, which is very convenient because we get this term. Okay, we get d0 is equal to primary surplus for 1 over beta, but let's just do one more little manipulation here. Okay, so this is the primary surplus is equal, this is our primary surplus is equal to beta minus 1 times debt, or okay, what we're saying here, this probably shouldn't have a, well, it doesn't need to have a star here, but what this is saying here is that given your chosen level of expenditures and given your initial level of debt, and your beta here, okay, this is your optimal tax, this is your tax rate. This is your tax rate that you would hold forever. Okay, this is your constant tax rate, which is what we want. Now, the last thing we need to do here is just unpack this guy. This beta minus 1, okay, if you do the algebra, it's equal to r minus g over 1 plus g. So what is this? This is the familiar debt state. This is a restatement of the debt stabilization condition. It just says, okay, if you have chosen a level of government spending and you have started off with debt, and this is your constraint, you have an interest rate, you have a growth rate, okay, and you have an initial level of debt, this will be your tax rate. It is the tax rate that you can hold forever, and coincidentally, you can also show that this is that when you do this, okay, this will get you constant debt, okay. And I realize now that I probably didn't, I should remind you that this is constant debt. All we need to do, well, okay, we need to go back to any of these periods, okay, and as we have d bar is equal to d bar, so we're putting a bar over this and a bar over this, times beta, okay, plus gamma bar minus tau star. And you can see that once we factor this out, d bar times 1 minus beta, okay, is equal to gamma minus tau. And then you can flip this around and you will get let's see, yeah, that you will get that the primary surplus that you have to run is equal to r minus g over 1 plus g. Okay, so that's the familiar debt stabilization. So hopefully what I've shown you here is that this that will get you stabilization debt, it is also has a much deeper rationale. It is the solution to a constrained optimization. So you're smoothing taxes, but you're smoothing taxes, but you're getting your first order condition, but you're embedding a constraint there. Okay. So now let's go back and take one. Let's do a little postscript on this. So we're getting this. This is equal to our tau star, which now we're convinced we've taken into account the long run budget constraint and the intertemporal the no Ponzi game condition, and then okay, and it's the same as that. Okay, this is lunchroom sustainability because this will stabilize the debt. Okay, but now, okay, is this really the right function that we want to be using? Okay, so if you take a close look at it here, okay, and this is what I argue in the guide to the perplexed, there is a first derivative and a second derivative. Okay, but there's no third derivative. Okay, which means what? First derivative, higher taxes, more deadweight loss. Second derivative, it increases at the margin. Okay, so you keep going up and up and up and up. The third derivative, which is absent, it will take into account volatility, or if you go to the literature on precautionary savings, you will learn that it's prudence. But interestingly, if there is no third derivative, there's no third derivative here. Do the calculus. If there's no third derivative here, volatility doesn't matter. Okay. So now, that's what I say is, look, okay, if you expanded this and you wanted to have some sort of alternative deadweight loss function where you worried about volatility, you worried about the ups and downs, and in fact you also worried more about the downside risk or the adverse risk than the positive risk, which means you worried more about the time when the debt goes up than when the debt goes down, you would end up with a term like this. You would have today's taxes equals expected value of futures taxes plus this term, this component that's related to volatility. So that means in terms of your fiscal rule, rather than this, okay, which is just trying to stabilize the debt, you would have something, you might have something like this, where your primary surplus is equal to, is this guy here, just enough to offset the debt plus this structural surplus. Okay, so this is for that. Okay, going deeper into how to the implications of that are for another video. Hopefully, we kept this video short enough. But the idea, once again, is that we've shown that the simple rule of debt stabilization actually has a deeper connection to an objective function. But then the question is it the right objective function? Okay, thank you very much.